Hello friends, welcome back to Ekeeda. As of now, we have seen the theory part regarding the consolidation. Okay, now let us start solving some problems. Now, let us first read the question. The time for the clay layer to achieve 85% consolidation is 10 years. If the layer was half as thick, 10 times more permeable, and 4 times more compressible, then the time that would be required to achieve the same degree of consolidation. Okay, so as the so many parameters are included here, let us just divide it one by one. So there is a clay layer. Let us assume there is a clay layer, and let us see in first case what is happening here. If it wants to reach 85% consolidation, how much time it took? It took 10 years of time, right? Now what they are doing? Now they are doing that in second case, the layer is half as thick. That means if it is having a thickness of T, let us say it is having a thickness of D. Now here the thickness will become the D by 2. Okay. Now, and 10 times more permeable. Suppose if the layer 1, if it is permeable, have K, then in the second case, it is having a 10 times more permeable. So 10K we can call it. And 4 times more compressible. So what is the compressible parameter we can consider here? Okay, now let us keep this term aside. I will tell you how can we consider this more compressible. What is the time required to achieve the same degree of consolidation? So if so, then how much time required? So after seeing all these relations, what is the term that striking your mind? So here for me, I'm striking that my time factor TV will be equal to CV into T divided by D square, right? TV is the time factor, CV is the, and T is the time required, and D is the length of the drainage path, right? Now, if I again express this CV, why? Because nothing is mentioned in terms of the CV. So again, if I replace the terms, so what I can call CV is nothing but a K divided by MV into gamma W into T divided by T square. So what are the parameters are required here? They are requiring that same consolidation. If consolidation is same, your time factor is constant. So what are the variable here? Your gamma W is constant. They have mentioned with respect to the permeability. They have mentioned with respect to the drainage factor, and they need the time required. And what about another parameter? This we can call it as a volume compressibility. So that's what they have mentioned here. So here, if it is of compressibility MV, so what is the compressibility in this case? Nothing but a 4 into MV. So for the same degree of consolidation, you can say TV is constant, gamma W is constant. So what is the parameter? Nothing but we have to find out the time. So if I take these two outside, so what I can call D square into MV divided by K. So that implies what can I express this equation? So I can express that time required in the second case divided by time required for the first case. That will be equal to drainage path is directly proportional. So we can say D2 by D1 whole square into MV is also directly proportional. So MV2 by MV1. But permeability is inversely proportional. So here I'll let it down KV1 divided by KV2. That will be equal to. What about D2? D by 2. D1 is D. So DD get cancelled. So how much you'll get? You will get 1 by 2 whole square into. What about MV2? 4 times MV divided by MV. So how much here it will be? It is nothing but MV gets cancelled 4. What about KV1? K. What about KV2? 10. So here it will be 1 divided by 10 as KK gets cancelled. So 1 by 2 whole square, 1 by 4, 4 gets cancelled, isn't it? That implies T2. What about the time required for 85% consolidation for the first case? 10 years. 10. That will be equal to 1 by 10. So 10 gets cancelled. So how much time is required? So if all these parameters are taken into consideration, So what is the time required? Time required is nothing but a 1 year. So here this is just a direct formula oriented based on the time factor equation. Okay, next move on to the next question. I think the problem is looking like very lengthy, right? Okay, now let us read it. A double draining clay layer 6 meter thick. That means there is a clay layer and the drainage is two-way here. Why? Because they are saying it is a double drainage and it is having a thickness of 6 meter. Settles by 30 mm. So the final settlement we can express it as a 30 mm. And what about the thing in 3 years? So for 30 mm settlement, it took 3 years of the time. Okay, fine. And what happened? Its final consolidation settlement has been estimated to be 120 mm. Okay, in 3 years, 30 mm is happening, but what is the final settlement? 120 mm. Now, what they're doing? If a thin layer of sand having negligible thickness, that means if I keep a sand layer in between, so if I keep the sand layer, what will happen? As the drainage path is increasing, time required for the settlement will decreases at a depth of 1.5 below the top surface. The final consolidation settlement will be. So what do you think the answer will be? So what will happen if you are including a thin sand layer? So if you are including a thin sand layer, that means your time required for the consolidation will decreases, but the final settlement will not change. So even though if we include the thin sand layer, so what will be the final settlement value? The final settlement value is 120 mm again. So don't do any stupid calculations like as I'm including the 1.5 layer. So for 6 meter 120, again for 1.5, how much it will be? So do not do such type of calculations. If you are increasing some sand layer, only thing is happens that time required for the consolidation will decreases, but our ultimate settlement will be constant. So what is answer here? Nothing but a 120 mm. Okay, understood? Move on to the next. A 6 meter thick clay layer undergoes 90% consolidation, okay, 4 times faster under two-way drainage as compared to one-way drainage. So in an identical clay layer of 15-meter thickness, two-way drainage will be faster as compared to the one-way drainage will be. So here let us see, let us assume there is a 6 meter clay layer and what is happening? 90% consolidation, what they are talking about? For 90% consolidation, 4 times faster under two-way drainage as compared to the one-way drainage. That means, suppose if it is a one-way drainage, let us say T1, nothing but one-way drainage. Let us say for one-way drainage, let us say, or let us say T2. For two-way drainage, let us say it is taking 10 years of the time for the final settlement. Let us read the statement what they are given. 4 times faster under two-way drainage as compared to the one-way drainage. So it is happening 4 times faster than this. That means 4 times slower than here. So here I can say it is a 40 years. So if it is taking 40 years time for reaching one-way degree of consolidation, then what about in second case 10 years? What is happening? In an identical clay layer of 50-meter thickness, two-way drainage will be faster as compared to the one-way drainage. Now tell me, our one-way drainage and two-way drainage, how they are dependent? They are dependent only on the drainage path only, right? So it doesn't matter what may be the thickness of the layer. Your two-way drainage is always 4 times faster than the one-way drainage. So again, what is the answer? 4. Okay, do not think that as your clay layer thickness is happening, your two-way drainage and one-way drainage, they won't change. Okay, always think that drainage, like how can I correlate it? I can use the time factor. What is the time factor? That is nothing but a CV into T divided by D square. For the particular clay sample, what will happen if it is one-way drainage? Your capital D becomes H. If it is a two-way drainage, your drainage length will be H by 2. That's it. So because of this, it is faster than the 4 times. By keeping TV constant, CV constant and T constant. So that's why again for this that is answer 4 years. Okay. Now let us read this question. Identical surcharges are placed at a ground surface at sites X and Y. Okay. There is a site X here and also there is a site Y. Fine. With soil conditions shown below and water table at ground surface. Okay, they are saying that water table is at the ground surface and they are given some properties of the soils. So what they are saying, the silt clay layers X and Y are identical. Okay, fine. The thin sand layer at Y is continuous. Okay. See here for the site Y, there is a thin sand layer is there at a distance of 5 meters from the top surface. The thin sand layer at Y is continuous and free draining with very large discharge capacity. Fine. If primary consolidation at X is estimated to be 36 months, so in a site X, how much time it is taking? 36 months. So what we have to find, what would be the corresponding time for the completion of primary consolidation at Y? So if you want to complete this one, then how much time will be required? Understand? So what will be the answer here? So how can we find it out? So what is the relations we have to use? We have to compare the time factor. Time factor will be, I can say it as a CV into T divided by T square. For this ultimate settlement, if you can see as these two are identical 10 meters and 10 meters, the final settlement will be same. See, final settlement will be same means your degree of consolidation is 100%. That means your time factor is constant. And what about CV? As both are same identical clay layer, your CV is also constant. So our time is directly proportional to the T square, right? Now, the thing is, what about the drainage path here? If you're talking about site X, what is the drainage path? As it is a bedrock, it is worked completely of one-way drainage. So for site 1 or for site X, what is the drainage path? That is nothing but a 10 meter. If you're talking about Y, what is the drainage path? If there is a water here, the instead of moving up to the ground, so it will water will discharge to the thin sand layer. So what is the drainage path in path Y? It is nothing but a 5 meter. That's what. So time required for the site Y divided by time required for the site X. That will be equal to, as these are directly proportional, drainage path for the site Y divided by drainage path for the site X whole square. For Y, 5 meter, for X, 10 meter whole square. So 1 by 2 whole square, 1 by 4. So what is the time required for the site Y? Tx. What is the Tx? 36 months divided by 4. That implies how much it times? 9 months. So because of the introduction of this thin sand layer, the drainage or the settlement will occur how many times faster? 4 times faster. So for that same degree of consolidation, if site X is taking 36 months time, but site Y will take only 9 months of the time. Understood? Okay, all these are basic problems based on the concepts of by using the time factor equation. Now let us see one more problem. A clay layer 5 meter thick in field takes 300 days to obtain 50% consolidation with condition of double drainage. If same clay layer is underlain by hard rock, then the time taken to attain the 50% consolidation. So what they are taking, there is a 5 meter thick layer. So if you want to get 50% consolidation, how much time is required? 300 days. So what is the drainage? The drainage is double, right? Then what about in the second case? If the same clay, that means if you are taking the same clay and it is underlined by the hard rock. So what is the difference between these two? As it is underlined by this hard rock, so our drainage path will be nothing but a one way. So that is what the difference. So what is the drainage path in this case? 5, 5 by 2, as it is a double drainage, nothing but a 2.5 meter. As here it is a single path, So out of the drainage path, that is nothing but a 5 meter. So how to correlate this? As the same degree it has to achieve. Your TV is constant. TV will be equal to CV into T by D square. As same clay layer, your CV is also constant. So your T is directly proportional to the D square. So as it is one-way path, the consolidation will happen 4 times slower than this. That means 4 times the 300. That implies how much time it will take. As it is a one-way drainage, it will take 1200 days to complete the 50% consolidation. Understand? So whatever the problems we have seen, all these are based on the time factor and the percentage of consolidation and final settlement. In the next video, we will see the problems based on the how to find the settlement. Thank you.